Right, hello everyone. Welcome to another live stream. Again, today we'll be continuing to work on the Python turtle. Please let me know when you're here. Please let me know who you are if your username doesn't show your name already. And yeah, today we're going to be continuing working on Python turtle like we started last week, or a couple of weeks ago we started it and we continued working on it this week. So a quick recap. I'll show you my screen. Quick recap, if we go onto the tiny URL, remember you can find in Student Resources Year 10 Practical. If you open up the PDF there, it will come up with Python Turtle. Scroll down and remember in our first week we drew a square with a red line and a brown fill color. Then we changed a couple of the lines. So we changed brown to blue and red to purple, and we changed these 100s to 180 so that it would become a purple line blue fill and sides measuring 180 instead of 100. So that was that task. Then we copied this code to draw a rectangle, noting that different sides of a rectangle have different lengths. So naming those different parts, and obviously still turning right by 90 degrees because it still uses right angles to turn. And then task 4, we added to task 3, so we had 2 rectangles. That was a bit more complicated to do. Red line, orange fill. We used our pen up and pen down. So if you remember your pen up and pen down, those two different things, we used those to make sure that the rectangles were not touching each other. And we had to go back and use some of our knowledge from task 1 of using the fill color, begin fill, and end fill to make sure that we had the fill in there as well. Then we had our triangle, where we noted that we only needed to go forward 3 times, 1, 2, 3, rather than, 4 times before, because we're drawing a triangle rather than a square. And going forward by 150 each time, just because that's how big we want our triangle to be, and turning right by 120, because that is the angle that we're talking about when we're drawing a triangle, the external angle of a triangle. Okay. Then when we get to task 6, we were drawing our different shapes, our pentagon, hexagon, octagon, decagon. And remember, we wrote in the amount of sides we had by just writing forward that many times, and then having our external angle in this section here where it says right. And remember, you could change it to left if you wanted to as well. So this lesson, we're going to continue working through this, but if you remember last lesson, we had to keep copying and pasting code over and over and over again to do something. Now, I'm sure you'll know by our normal lessons that that is not the most efficient way of doing our code. So the best way of doing it is to repeat instructions using a loop, okay? So writing out the same instructions is not efficient. It even says it in the booklet. So we use this program to write our instructions in the form of a loop. So the code on lines 3 and 4 are indented. That gap there is our indent. It's important. We need to know that these lines are repeated. So I'm going to copy that, put it into my thing. You'll notice that if I copy and paste, then it hasn't kept the indentation. So you might have to go back and work out where the indents are. So you have to put them in yourself by typing in tab, which is just above your caps lock key. Now, if we run that code, that is the same code that we used at the very beginning up here. So all let's go back to this bit here. All of that has been reduced to these 3 lines here. So instead of writing, I think it's 4, 5, 6, 7 lines of code, we can reduce it down to 3, which obviously is much better to work with. So that is effectively just task 7. That is just showing what happens when you use your for loop. Now remember, for I in range will create a loop, and it will make I become 1, then 2, then 0, then 1, then 2, then 3, because Python usually starts counting from 0, and it doesn't go up to the 4th item. Okay. What I'd like you to do is have a go at task 7 and task 8, and just let me know once you've done it. Now with task 8, it asks you to have a look at the program, try to work out what it will do. Think about when the turtle will be drawing, when it won't. So you've got your pen up and pen down here. Which lines of code will be repeated and which won't. So bear in mind which bits have the indent at the beginning of them. So what I'd like you to do, maybe on a separate piece of paper or something like that, or maybe in the air, like draw with your finger, figure out what it is that this code will do before copying it into Trinket and running it. So I'm going to give you a few minutes just to do task 7 and task 8, and then maybe you can move on to task 9 after that. So let me know how you're doing so far. This is in the practical folder. It's in the practical Monday, Tuesday folder for you to complete that. This is the Python turtle.pdf in the practical folder. And for you to, from task 7 and task 8, hopefully you should whiz through task 7. Basically, I did it for you. It's just copying and pasting, understanding what it's doing, which you should be able to do because you should know what for I in range is. A reminder, the tinyurl.com/berrycs. If you can add it to your own favorites, that would be really useful. Task 8 is having a look, predicting what you are doing before you run the code. Okay, So I'm going to give you a few more minutes. I'm going to run another non-copyright music. I thought it'd be nicer to have non-copyright music than me just sitting here in silence. So let me know once you're done, but carry on task 7 and 8. Okay, so hopefully you've managed to create that, the program below where, so in task 7, we just created a square using much less lines than we did in our previous lesson. In this one, hopefully you predicted before you started running the code, which was to, you predicted that because you're lifting the pen up, then going backward by 300, then going back down again, that you're starting at a different point on the canvas. So usually you might start in the middle, but it's actually going to start on the left-hand side instead of the canvas, so that when you draw your squares, sorry, I'm going ahead of myself there. When you draw whatever it is you're drawing, sorry, then it will draw it in, it will fit better on the screen rather than going off the edge. So, so that's that part. Pen up, backward, pen down. Then you've got your for I in range 4, blah, blah, blah. All of that. That is the exact same code as up here. So you should have recognized that that creates a square. Then pen up, again, going forward by 150, then pen down. So that is all that's doing, is leaving a gap between this square and the next part, which is, again, also a square. So hopefully you should be able to see. Let me just take all of this code here, if I can. There we go. And copy that. I will select all of this, paste it in. Ooh. Oh, maybe I didn't copy it properly. Copy, paste. There we go. And don't forget, if you're pasting, you need to make sure you know where your indentations are, because they don't paste in properly. Okay. Now, I might need to zoom back out on this to see this running properly, but let's see it. Again, you can't quite see it all the way through, but you should be able to see both squares. Because of the way Trinket is set up, it doesn't show the same way as usual. Then we can go into, so I'm going to change this, instead of 300, I'm going to change it to 100, and I'll run it again, and you'll be able to see a lot better now. So you can see it's also, because it moved forward by 150 when it lifted the pen up, that is bigger than the length that it drew, so the 100, which is obviously much better for the squares than it would have been. Okay, so that's literally just drawn 2 squares. So hopefully, now that you've been able to do that, draw 2 squares, and what you've done here is you've drawn 1 square, lifted the pen up, moved forward, put the pen down, drawn another square. You should now be able to draw 4 squares. So I'd like you to have a go at task 9. Now there are 2 ways of doing this. There is an easy way, which is using what you've got here to your advantage. And there is a slightly more efficient way, a better way to be able to see your code is more efficient. It looks a lot nicer. So I want you to have a go at task 9 for me now, please. Okay, how are we doing at the moment? Don't know how many of you have managed to do those 4 squares, but I'd like to be able to see how far through the lesson we can get. So 4 squares is basically just the same as 2 squares, but instead of doing this twice, you're going to do it 4 times. So this section here, I can just copy and then make sure it's on the right level and paste. And I'm going to do that one more time because I've got my 4i in range, blah, blah, blah. And then I've got 4i in range, etc. So so I've done that 1, 2, 3, 4 times. So hopefully you had a go at doing that as well. And you should then see, if you've got yours at 100%, oh, something went wrong there. Let's run it again because I think there was something didn't quite work there. I may have to check through my code to make sure I haven't messed something up. Oh dear. Oh, I know what's happened. Okay, I'm going to reduce the size of my squares so that I can see all of them. So I'm going to change these to 10. Then it'll be a lot nicer to be able to see what's going on. I'm going to change these to 15 instead of 150, just because they're so big that that's made a huge difference. So now I've got very tiny squares, but you can see that they're still squares. If I maybe made these 50 instead of 10, 150, 50. And then so I've got 1, 2, 3. Oh, I haven't done this one. 4, and then change these to, I don't know, 60. Just as long as it's bigger than the amount it's going forward by. And this one. So again, just a little bit of trial and error there, but you can see now I've got 1, 2, 3, 4 squares. Okay. Now this code there's a lot of code here, and you can generally see, I mean, we did it ourselves. We copied and we pasted. We just did the same thing over and over again. Now what we could do, if we were to add this code to the end, this bit of code to the end, you would see that nothing extra would happen. So if I do that, we've not changed anything. The turtle will just go a little bit further, and so you can see it ends here instead of ending over here. Now you can see this bit of code is just being repeated. 2, 3, 4. Okay, so I can just get rid of the majority of that code. My keyboard's not connecting. And then tab all this in and create another 4i, but I wouldn't create it as I would say it as a different value. So for I don't know, 4j in range. And because we're drawing 4 squares, all we're doing is copying this code 4 times. Now the reason you might not be able to see yours is because the trinket screen is a lot smaller than the usual screen for these tasks. So if you were to run this in Python instead of Python that's installed on the computer instead of Trinket, which is on the in the browser, then you might be able to see it a lot better than you would normally. So if you can't see it, I would suggest reducing the size of your squares, reducing how far your arrow goes instead of having to go too far. Okay, so because it kind of cuts off over here, that's why that's one of the issues with using Trinket instead of using this in real Python. I would just get you to install real Python, but that would take a whole lesson in itself. So, and I'd rather get into doing some actual coding. So we're just getting around those issues by using Trinket. Okay, so we've drawn 4 squares. In fact, I didn't run this code, did I? So 1, 2, 3, 4. And you can see that it's done that because it's repeating this bit of code 4 times, and we know this bit of code is just like saying create a square, okay? And this bit of code is just like saying move along to the next space to draw the next square, okay? So that is that piece of code. Now, task 10 is a bit more interesting. Now, a hint with task 10, it's given you this hint that when drawing these 5 sides, there are 5 sides here, so the square has 4 sides. This star has 5 sides. The turtle turns through 360 degrees twice. So usually we did a bit of, I don't think we've done a calculation, have we? No. Interesting. So our calculation here is working out how many times this turns through 360. Now, on a square, you turn through 360 once because you never go back again. And the same with your triangle, with your pentagon, hexagon, octagon, decagon. If you work out then the amount of sides and the angle, so if you were to say 360, so all of these have been 360 so far, and there are 5 sides. If you were to do the maths there, 360 divided by 5 is 72, okay? That's what your external angle is. If you were to do 360 divided by 6, let's change that, divided by 6, it gives you 60, yeah? So, and you can do that for any of these number of sides. So with task 10, we're doing it twice. There are 5 sides and it's turning through 360 twice. So instead of having our 360 divided by 5, like we did a minute ago, which is 72, we need to have our 360 degrees twice. So you need to work out what 360 and then twice, and then split that into 5 sides, okay, to work out what your angle is going to be. Okay, once you have created that star, I want you to move on to task 11 as well. Task 12 is a bit more complicated. I need to give you a clue on that one, a bit like this clue, but hopefully you'll be able to work out task 10 and task 11. Task 10 might involve a little bit of trial and error using this calculation here. You need a little bit extra on that calculation. But task 11 should be very similar to task 9, but instead of going forward 4, we're going to have 5 sides, and we're still drawing 4 stars rather than 4 squares, so that would stay the same. And then this bit here would be 5, because drawing a triangle, not a triangle, a star, sorry, which has 5 sides. And your right value would be whatever this calculation gave you, okay? So have a go at task 10 and task 11. Let me know when you are done so that we can move on without me, you just sitting there doing nothing for ages and everyone's just sitting doing nothing. That would be a bit silly, wouldn't it? So have a go. Task 10, task 11, off you go. Right, guys, hopefully you've managed to create your beautiful stars with 5 sides turning through 360 degrees twice, which is, of course, 720. So 720 divided by 5 is 144. So that is the angle you should have used to turn through 360 degrees twice. So instead of doing, I'm just going to change this back a moment. I'm going to open up a new tab because I don't want to lose this bit, but I am going to just basically copy this. So import turtle, and then I'm going to do for I in range, and then instead of 4 I'm going to say 5 because we're drawing a 5-sided shape rather than a 4-sided shape. Yeah, and then it should automatically go onto your next line for you if you're typing it out rather than copying it. And then I'm going to go forward by 50 because that's a nice small number. So turtle dot forward, and I'm going to say 50. And then instead of turning right by 90, because that's what a square gives us, obviously if you turn right by 90 you get a square, but we've got our drawing 5 sides. This is a bit more complicated than the ones we've just been doing. When drawing 5 sides, the turtle turns through 360 degrees twice. So a way you could say it is 360 times 2 and then divided by 5, okay, which gives you the same answer of 144. Okay, so instead of going right by 90, I'd like us to go right by 144. So turtle dot right 144, close brackets, and then hopefully that should draw us our star. So I'm going to run it. You can see I've drawn a star. It's a bit smaller than the one in the example, but that's because I reduced the size so that it would fit on the screen when we make our one later. Okay. Then I'm going to use this code that we had here to do our task 11. Task 11 is going to be very similar to task 9, but instead of using what we used for task 9, where we had this bit to draw our squares, we're going to have the same code that we use for task 10 to create our 4 stars. Sorry. So we're creating 4 stars, aren't we, rather than 5? So that's still okay. And then I'm going to change this here for I in range 5, and then I'm going to go forward by 50 and right by 144. So if I change this 144, and then let's see, am I happy with that? Yeah, I'm probably happy with that. So going forward by 60, that still should leave the same amount of gap as it has here. So if I run it, goes back to the beginning, creates my first star, leaves my gap of 60, creates the second star, leaves a gap of 60, etc., etc. And don't forget, we've got our 4. So what we're using here is a nested loop. So we've got a loop here that's inside another loop. That's what we call a nested loop, which means that it's just repeating something inside itself. So the fact that we've drawn this star here is just this bit of code here. But to be able to draw it 4 times, we just put it into this loop here. So hopefully you can kind of see that that is how that works. This loop is just saying do all of this code here 4 times, because it's saying for j in range 4. For I in range 5 is telling us to draw the triangle. I keep saying triangle, I mean star. Okay, so it's going forward by 50, which is our going forward, and then it's turning right, and when it turns right, it goes to the correct angle, and then it will go forward by 50 again, and then it will turn, go forward by 50 again, and it will turn, and it will go forward by 50. Can you see the idea that's happening there is very similar to what we did for the squares, where all we were doing was repeating that piece of code. But because all of these angles are the same, 144, we don't have to keep writing the code over and over again. Okay, so hopefully that's given you an idea of how that works a little bit better. With task 12, this is a little more complicated. I need to give you a bit more information here. So when drawing, so there are 20 sides on this. And when I first did this, I had to use a little bit of trial and error because I didn't know what the angle was going to be. So there are 20 sides to this shape here, this funny 20 pointed star. And I think it's 20 pointed star. So, and it turns through 360 degrees 11 times. So you're using this same thing here. So it's turning through 360 degrees. It's not turning through twice. It's turning through 11 times. And it's not got 5 sides. It's got 20 sides. So that is how you calculate that angle. And don't forget, you're drawing 20 lines rather than just 5. So if you go back to this bit here, that should allow you to use that bit of code there. Change just a couple of things. All you need to do is change this number and this number, and you should be able to create this item here. It is not quite as complicated as it looks, but you just need to be able to utilize this value here. So a reminder that you're using that it's 20 sides and that there are 11, it goes through, turns through 360 degrees 11 times. Okay, so have a go at that. I want to see what you can do. Will be interesting to see your code. If you can send that to me via Show My Homework, the link to your trinket, by clicking up here, click link, and then just copy this link here. That allows me to see what your code is. If you just copy that and send it to me via Show My Homework, you won't be able to post it into the chat because YouTube won't allow us to see links in the chat. But hopefully it'd be interesting to see your code if you've done it differently. It's probably not super different the way you've done it, but it'll be interesting to see what you have done. So yeah, task 12, have a go at it. Don't forget you've got 20 sides and it's turning through 360 degrees 11 times. Have a go. Right. Hopefully some of you have got some lovely stars going. Maybe some of you haven't quite got that 20 pointed star, but we're going to go through and I'm going to show you what we need to do here. So don't forget we've got 20 sides and it turns through 360 degrees 11 times. So it's turning through 360 degrees 11 times, not 2 times, and it's dividing by 20 because there are 20 sides. So our angle is very specific, 198, so that is the angle we're going to use here. Instead of 144, it's going to be 198, sorry. Yeah, that was right, 198. And of course, because we're drawing a star with 20 sides, instead of being in range 5, we're saying in range 20. Okay, and we can just press play, and we should have our 20-sided star. I might need to make this a bit bigger so you can see it better. But yeah, I'll need to make this a bit bigger because it's a bit too small now. I'm going to make this a bit bigger. Let's change this to 100. Let's try that again. You can just about see that it was 20 sides there. So you can start to see that it's pretty much the same shape. Might be lines are a little bit thicker, but you can see that it's pretty much the same shape. If you were to go through and count, then you should be able to count 20-sided or 20-pointed star. Okay, so that is that one. Now, task 13. This one involves a little bit of thinking. Oops. A little bit of thinking about how these squares are drawn. So you've got your first square, which you can use this bit of code. Now each square is a different size. How do you make sure that each square is a different size without just typing in loads and loads and loads and loads of code, like over and over again? Think about how usually we use I, and sometimes if you print out I, what do you get each time? So think about that when you're drawing your squares. So your smallest square is probably about 10 pixels wide. Then it'll be 20, then 30, then 40, then 50, then 60, 70, 80, 90. Okay, see if you can have a go at that. I'm not going to give you very long because we're almost at the end of our lesson, but I want to just see what you can do, what you think you can do with that. Have a go. Right, I'm going to stop you there. Hopefully you had a bit of a go at that. I know that this one I probably didn't give you enough time to actually do this properly, but we'll see how far you got, and I can show you what this should look like. So I'm going to create a brand new trinket. Now, first thing I'm going to do is draw my square. Now, how do I draw a square? I can go back to task 7 to just draw my square. So import turtle for I in range 4, turtle.forward, and then turtle.right. Okay, so that's how we draw a regular sized square, 100 wide. Okay, now we need a loop to be able to draw lots of squares, right? Now I'm drawing, I'm going to say I've gone from 0 to 9, which means that I'm drawing 10 squares. So I'm going to add an extra line here. I'm going to say for j in range 10, oops, not L, and then I'm going to indent all of this. So select all of that, press the tab key, which is above the caps lock key on my keyboard, and then that will draw the same square 10 times. Okay, now that's not helpful because I don't want it to draw the same square 10 times. I want it to draw a small square, then a slightly larger square, then a slightly larger, and slightly larger, etc. So instead of drawing the same square 10 times, I want this value to keep changing every time. Now what can we use here? If I was to print j here, then you would see it's 0, then 1, then 2, then 3, then 4, etc., etc. Now, if you think about what these values are, and it should end at 9. It shouldn't finish any earlier than that, or later than that even. So you can see it stopped at 9. Okay, so I've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If you think about those values and think about the sizes that we want, what is the difference between those values and the sizes we want? So 0, let's ignore 0 for a moment, and we'll come back to that in a minute. But 1, what's the difference between 1 and this smallest one? What's the difference between 2 and the second smallest one? So this smallest one, we want that to be 10 pixels. Then we want it to be 20 pixels and 30 pixels and 40 pixels. So what we can do, we can utilize j, and we can just times it by 10 to get our values. And instead of saying 4 by 100, we can just say j times 10. And if you times 0 by 10, you're going to get 0. So at the very beginning, it will create a non-existent square that's literally just be a dot. So if I run it, again, it shows that non-existent square. It's got my tiniest square, bit bigger, bit bigger, bit bigger, and so on until it draws my full sized 90, I think it's 90 by 90 square. Okay, and there you go. That's our square drawn the exact same way. It's slightly thicker lines, so it looks a little bit more funky, but it is the same thing drawn there. So hopefully you can kind of see what I've done there. That J I've utilized here because J changes every time. And then I've just drawn my I in range. That part there is the bit drawing the square, and the only thing changing is the size of the square, which is that forward bit. Okay. I've gone over time, so I'm going to stop there, but I really hope you found that useful. If you want to talk about anything in particular about today's lesson and you want to show me any of your code, you can always click on this bit here, click on link, and then copy this code over, this link over into show my homework, and then ask me any particular questions you have about it. I'll be happy to answer it. You do need to use show my homework to do that though, because it won't allow you to post links into YouTube's chat. And I'm going to be signing off now anyway. So I really hope that's useful. I hope that this allows you to think a little bit more about having loops inside loops and how that could be really useful rather than having to write for drawing a square once and then having to change how far forward it goes and keep changing that over and over again. Okay, as I said, I've gone over time, so I really hope you have a good couple of days before I speak to you again on Friday. Friday we will be continuing with our theory topic of algorithms, so we'll be continuing there, and same sort of idea as it was last lesson. See you on Friday. Bye.